Hello everyone, welcome back to my channel. This video is part 1 of a 3-part video series covering all questions from the 26th Philippine Math Olympiad qualifying stage. This covers part 1 of the questionnaire consisting of 5 easy questions. Here I will show my full solution to each problem. Okay, let's start. Question number 1. Let a, b, c be positive integers such that 3.14 is equal to a plus 1 over b plus 1 over c. What is a plus b plus c? We just need to convert 3.14 into a mixed number. So 3.14 can be written as 3 plus 14 over 100. And then we can simplify 14 over 100 into 7 over 50. So we have 3 plus 7 over 50. Now, we can write 7 over 50 into 1 over 50 over 7. And then 50 over 7 can be written as 7 plus 1 over 7. 50 over 7 is just equivalent to the mixed number 7 and 1 over 7. And 7 and 1 over 7 is just the same as 7 plus 1 over 7. So here, a is equal to 3, b is equal to 7, and c is equal to 7. Which means that the sum a plus b plus c is equal to 3 plus 7 plus 7, which is equal to 17. So the final answer here is answer choice C. Problem number 2. What is the area of a rhombus whose diagonals have lengths 14 and 48 respectively? This is a fairly standard problem, and recall that there is a well-known formula for the area of a rhombus. The area is given by 1/2 times d sub 1 times d sub 2. So we have a equals 1/2 times d sub 1 times d sub 2, where d sub 1 and d sub 2 are the diagonals. Now we can just let d sub 1 be equal to 14 and d sub 2 be equal to 48. So we have 1/2 times 14 times 48. So we have 7 times 48, which is equal to 336. So the answer here is answer choice B. Problem number 3. The arithmetic mean of 11 integers is 10. After adding 20 to each of the first 4 and subtracting 24 from each of the last 7, what is the new mean? Let us determine first the sum of the 11 integers. So the sum of 11 integers is just 11 times 10, which is equal to 110. Now, since we are adding 20 to each of the first 4 and then subtracting 24 from each of the last 7, then there will be a new sum. So how do we get that? So the new sum is equal to 110 plus 20 times 4, since we are adding 20 to each of the first 4, and then minus 24 times 7, since we are subtracting 24 from each of the last 7. So this is equal to 110 plus 80 minus 168. So the new sum is 22. Therefore, the new mean is equal to 22 divided by 11, since there are 11 integers. So the answer here is 2. And that is answer choice A. Problem number 4. Let A and B be the last two digits of the 5-digit number 764AB. What is the largest possible value of the product AB squared if the 5-digit number is divisible by 6? Since the number is divisible by 6, we know that 764AB is divisible by both 2 and 3. Alright. Now, since the number is divisible by both 2 and 3, we know that the number is even. So the possible values of B are 0, 2, 4, 6, and 8. But then we want to maximize AB squared. So we will take 8 as the value of B. Now, since 764AB is also divisible by 3, we know that the sum of its digits is divisible by 3. That is 7 plus 6 plus 4 plus A plus B is divisible by 3. Okay. Now, simplifying this one, we have 17 plus A plus B. But then we have determined that B is equal to 8. So we have 17 plus A plus 8, which is equal to 25 plus A. Now we just need to determine the value of A such that the sum 25 plus A is divisible by 3. But we need also A to be a maximum. Now, obviously, you can easily check that A should be 8. Because if A is 8, we have 25 plus 8 equals 33, and 33 is divisible by 3. So these are the values of A and B that we are looking for. So now we can compute the maximum value of AB squared. So AB squared is equal to 8 times 8 squared, which is equal to 512. So the answer here is answer choice C. Problem number 5. An urn contains 2 white and 2 black balls. John draws 2 balls simultaneously from the urn. If the balls are of different colors, he stops. Otherwise, he returns both balls to the urn and then repeats the process. What is the probability that he stops after exactly 3 draws? Alright. John only stops after 3 draws if he draws 2 balls of the same color in the first and in the second draw, and then he draws 2 balls of different colors in the third draw. So let's determine the probability of getting the same color in the first and in the second draw, and then the probability of getting different colors in the third draw. And then we will just multiply the 3 probabilities to get the probability that he stops after exactly 3 draws, since the 3 events are independent. Alright, so first draw, let's get the probability that, or the probability of getting 2 balls of same color. Okay, so that is just 2 divided by 4 choose 2. So 4 choose 2 represents the total number of ways that John can draw 2 balls out of 4. And then why do we have a numerator of 2? Because there is only one way of drawing 2 white balls and then another way of drawing 2 black balls. So all in all, there are 2 ways of drawing 2 balls of the same color. So the probability is 2 over 4 choose 2. So 2 divided by 6. This is equal to 1/3. Now, in the second draw, we look for the same probability. We look for the probability of getting two balls of the same color. So we still get 1/3. So we don't have to repeat the process here. We know that this is still 1/3. Right? So 1/3, 1/3. Now in the third draw, we will get the probability of getting 2 balls of different colors. Getting 2 balls of different colors. And that is just 2 choose 1 times 2 choose 1 divided by 4 choose 2. This is equal to 2 times 2. So 2 choose 1 is 2 times 2 choose 1, which is also 2, divided by 6. This is equal to 4 over 6, which is equal to 2/3. Okay, so now let us just multiply these 3 probabilities to get the probability of the desired probability in the problem. So we have the answer 1/3 times 1/3 times 2/3, which is equal to 2 over 27. Right. Okay, so the answer here is letter B.